And we're taking a look at page 193 in the textbook. We're going to do a walkthrough of this example. We have the data. The author gives us null and research hypotheses. They talk about the level of risk, selecting our test statistic, they compute it, and then they reflect on the results and make a decision and report the results for the test. Now remember, we're running tests. So on page 193, we've got group 1 and group 2 for Alzheimer's patients, and it's talking about how they're able to remember the order of daily tasks. Group 1 was taught using visuals, and group 2 was taught using visuals and intense verbal rehearsal. So we might think that maybe they're going to be different, or one's going to have a better performance than the other. Now, if you look at the data on page 193, all of group 1 data is put into 3 columns, as is the data for group 2. That's a format decision because it's printed in a book. When we go to run the test on our data, we're going to put all of group 1 data into one column by itself, and all of the group 2 data in a column all by itself. Now, this is important for the homework exercises for this chapter. Anytime the data, you have multiple groups, what you want to do when you're running your tests using technology is to put separate columns for your different groups. So all of the group 1 data will go here, and all of the group 2 data will go here. That little idea will help you a lot when you're doing the homework for next week. Same thing for when you're working on your write-ups. For your multiple groups, you want to have them in separate columns. It's a nice rule of thumb. So page 193, we have a null and research hypotheses. So for the null hypothesis, again, this is not write-up quality. I'm speaking and typing here. But the null hypothesis is that the mean for group 1 is the same as the mean for group 2. Another way of saying that in terms of the language that Excel uses is we would say that the difference between the two is 0 because they're the same. The research hypothesis, and we could talk about this, and if we want to run a certain one-tail or two-tail test, we could make that decision as a class and do that. For the textbook on page 194, they say that for the research hypothesis is that the two means are not equal. So group 1 mean, see if I can get this to work here. Is not equal to the group 2 mean. So those are our two hypotheses. Remember, when we run a test, we will either reject the null hypothesis or fail to reject the null hypothesis. Really, our hope, or our presumed or assumed goal is that we're hoping to reject the null hypothesis. So there we have, and this is a two-directional or two-tail test that we're going to run. So the textbook suggests to follow the flow chart on figure 11.1, which is on page 191. For this particular test, we have 2 groups, so we're testing between 2 groups. There's no relationship, there's no matching between corresponding values. So this fact that this is a 7 from group 1 doesn't matter, that this is a 5 from group 2. They're not related. It's not the same person or anything like that. Since we don't have that linking with the data, we're going to run a t-test for 2. And this is going to be, it's not the matched pairs, and we're going to assume unequal variances. So I think we're ready to run our test. We're not going to do this. You don't have to do this by hand. We're going to use the software for us today. We're going to go right back to our analysis tools and wait for the computer. Oops. Wait for this to open up for us. Just like with the M&M data, we're going to be running the t-test for, I believe it's for independence, and this is with unequal variances. As soon as this opens up for us here. Again, when you type this data or access this data, always make sure to verify that it is correct, because if we have wrong numbers or wrong data, running the test is completely really meaningless, because we're gonna make our decisions based off of incorrect information. Okay, so we're gonna do a t-test, a 2-sample, assuming unequal variances. Variable 1 range, we're going to use the group 1 data. We have 30 values, and we're including the labels. For variable 2, this is group 2 data, which is in column B. Again, our hypothesized mean difference is 0. We're including the labels. We're keeping this alpha level of 0.05. Now, for one of your homework questions, it's going to ask you to run a test with 0.05. And then it's going to ask you to go back and change your critical value to 0.01. Well, that's your alpha value, so that's what you would change there. But again, for this one, as they've done in the textbook, they have selected this critical value of alpha as 0.05. And then we just select where we want to put the results. I'm going to put the results in this cell, which is D5. And we're going to run the test. Now remember, 2 things. Our research hypothesis is two-tailed, so that's where we need to go in our results. And our critical value is 0.05. We're going to run the test. So here's our test. Now we have the 2 means. That's nice reference information. And you can see that the variances are pretty different between the 2. And here is our p-value for the 1-tail and the p-value for the 2-tail. This is actually the value we want for our 2-tail test. I'm going to highlight this for us. Now we have to be careful when interpreting this. We're comparing this 0.89 to this 0.05. Well, this is much larger than 0.05. What that means is that we fail to reject our null hypothesis. We fail to reject our null hypothesis. Now we're going to compare this information with what the textbook has. This is the t-statistic, which is related to the bell curve that we talked about last week, which is really kind of essentially our basis for running these tests. Now this t-statistic allows us to come up with this p-value here. So you can verify that this t-statistic agrees with the one that's reported in the book on page 194. They give us negative 0.137. And then the p-value, did they give us? Yeah, so on page 196, they give us that p is greater than 0.05. So we'll talk about that in just a moment. df is the degrees of freedom, which we have right here. And now we've really already done our comparison. Our p-value was greater than 0.05, so we're going to fail to reject the null hypothesis again. So that's our decision. We failed to reject our null hypothesis. Now on page 196, how do I interpret this? Well, that's based off of that t-value. for the purposes of our class, we're just going to look at this p-value. All we have to do is compare the p-value with our alpha here. And so what the textbook says here is the p is greater than 0.05 indicates that the probability is greater than 5% that on any one test of the null hypothesis, the two groups do not differ of the way they were taught. Really, since we failed to reject the null hypothesis, we do not have statistical significance. So we don't have enough, we don't have a strong enough results here to reject the null hypothesis. So we would still assume that the group 1 mean is equal to the group 2 mean. And that is the test for the textbook beginning on page 193.